Good morning, good afternoon. Welcome to our Rev Up series for FMEA label print quality today. We're doing a webinar. I have to apologize in advance. You're not going to be able to see me or my panelists today. We're having issues with our GoToWebinar camera settings internal to the device. But I can tell you this is what I look like. I'm your speaker today, Andy Schmidt, Product and Business Development Manager at TSC. My background is in chemistry, and I started my career doing mostly label design, but have been in the auto ID and barcoding space for over 12 years, working on various challenging challenges from the design of the labels themselves, the structure of the labels, to the printing of them, scanning, etc. And happy to talk about this really important topic today. With me from the panelists, our partner Travis, and I'll have him introduce himself.
Great. Thanks, Andy. Appreciate it. Hi, I'm Travis Wayne from TechLinks. I'm the product manager here for all of our label design and enterprise products. I've been with TechLinks for a little bit over 7 years. Prior to that, I was in the healthcare field for 15 years in IT and project management. So I really have a passion for connecting things together, bringing partners together, and luckily enough, have an opportunity to work with TSC and Andy, and was able to join Andy at the AIAG Summit just recently, the Quality Summit, and got to meet a lot of you folks out there as well. In my spare time, I do like to research things, whether it be just something for the house or a home project or a new technology. So kind of like to dig into it a little bit deeper and learn all about it. So thanks, Andy.
Yep, thanks, Travis. And before we get into our agenda, just a few housekeeping items. You'll see the panel to the right allows you to ask questions to the chat. We'll answer as many as we can as time permits at the end of the webinar, and then of course follow up with the question and answer to send a copy out after the webinar is over. We also have some polling questions. They're just going to pop up on your screen, and they're all multi-choice, multi-select. So you can answer as many of these things that are relevant to you. You can also check out the handout section on the right or at the bottom, depending if you're using either the GoToMeeting web client or the installed client, and you'll see handouts. Again, these will also go out in an email to all the attendees. With that, the agenda, we're going to start out with a quick background on quality tools to kind of segue how FMEA fits into the broader scope of tools that you have to improve your quality function. We'll talk about common failure modes for labels and barcodes and how this would fit into using an FMEA type process in order to improve these. And then we'll go through an actual FMEA and do some of the scoring and talk about some common controls that you might already be using for label issues, and then some remedies and things to improve your RPN scores, your risk priority numbers, and we'll get into that and what that means in a little bit. But first, just to do a quick company overview, who is TSC? Well, we're a leading provider of thermal printing solutions. We've been around since '91, formed from the original programming languages for thermal printers that were used around that time. And our brands include TSC Printronix, more on the enterprise side, and supplier companies DLS and MGN that makes labels and ribbons that work really well on our printers. And of course, we have Travis from TechLinks, who will talk to you a little bit about the software side.
Yeah, sure. So TechLinks has been in business for many years, working closely with partners such as TSC. Had the opportunity to work with Andy Edwards at TSC, and we had an idea to bring one of the solutions together that we'll touch upon a little bit later, utilizing their ODV2D. But from a TechLinks perspective, we create label design and print software for barcodes, RFID, of course, 2D codes such as QR codes. It allows you to integrate with your ERP systems, your warehouse management systems, and we have a full repertoire of products all the way from the design to the ability to track and audit what's being created from a label perspective and printed from a label perspective, to also exposing those label templates to your supply partners. So some of the brands that we have are Label Matrix, Label View, CodeSofts, and won't read them all, but really looking forward to being here, and thank you so much for joining. From a partnership perspective, we have, I don't know the exact number, but many drivers, native drivers within our softwares that can drive the TSC and Printronix Auto ID products. So that gives you optimized print speeds. It's sending what the printer expects to receive from a communication perspective. And you're able to control all of those settings within the software and save them. So, and I think that's it. Anything you want to add, Andy?
No, I think let's get into it. So, in the automotive space, there's a lot of different quality tools at your disposal. As AIAG members, Travis and I, we work on some of these things in terms of, um, you know, process improvements. But what I really love about being an AIAG member is you have access to all this body of materials out there for helping improve quality. So perhaps you've seen the house diagram, quality functional deployment. I suppose a lot of you have. There's a lot of core tools that you use every day for a continuous improvement mindset. An example of this would be statistical process control, control charting, um, basically being able to measure your system over time, the health of that system. Most of you are likely already employing some kind of production part approval process or PPAP. You'll work with APQP to reduce the cost of quality. But today we're really going to focus on failure modes effects analysis. And this has been a really strong tool dating back a long time ago to the 1940s, as we'll learn. And it can be a really nice preventative method as opposed to some of these tools that can be more reactionary, like a Pareto diagram, for instance. You only know you're failing quality once it's a problem, whereas FMEA is really designed to catch things before they become a problem. Because ultimately, quality means doing it right when no one else is looking, not just when the house is on fire, but preventing these mistakes from happening in the first place. So I'd like to start with just a poll question to get some participation here. I'm going to launch this poll, and the question is, what has been your go-to tools or process for your quality function or your continuous improvement goals? So take a minute to answer this poll question. We've got about 20% of the people that put in their answers so far. I am going to share this back with you so you guys can kind of see what your colleagues are looking at in terms of what are their go-to tools. And I'll tell you kind of my view on this question in a minute as well. For instance, I sometimes use this question as a probe to a supplier that I want to work with to kind of understand their philosophy around quality. All right, 10 more seconds. Get those votes in. All right, I'm going to share results. So we have a bit of a tie here. Kaizen and 5 Whys, I think those are always good processes to employ. Lean Six Sigma, Fishbone. Maybe most folks aren't as familiar with A3 process. Share again. Okay. Um, but I'll tell you, I think with regards to my favorite quality tools, it depends on the job, what you're trying to do. And all of these things are really important. 5 Whys to get to the root cause, I think, is really important. Kaizen, I just think, helps set up you culturally for success. but ultimately the thing that you're trying to solve for will kind of dictate the best quality tool or continuous improvement tool. And the more tools you're exposed to, like FMEA, the easier it is for you to improve your quality and to to mitigate some of these issues that we're going to talk about today. So back to the talk. Um, Not too many people are familiar with this unless you're a barcode nerd like Travis and myself. But barcodes are actually celebrating their 50th birthday this year. Going back to Troy, Ohio, where the first pack of Juicy Juice was scanned, the UPC was scanned in a grocery store. And you think about that as a turning point in operations and industrial and manufacturing and retail, specifically in automotive. Now these barcodes, these codes, they exist everywhere, and they've powered so much of our use cases, not just in shipping and logistics, making sure we're getting stuff just in time, but managing a traceability program and being able to track things back, which has dramatically increased the safety of our vehicles, reduced warranty costs, reduced recall costs, and the use cases for barcodes just keep expanding. And there's some interesting ones that TSC is working on right now in automotive in terms of machine vision and robotic assembly and auto detection. But even things like inventory management, configuration management, knowing what kind of tires you have on the shelf, tracking your tools, doing preventative maintenance in sort of more MRO type applications. These are all really important use cases. And so it's really important to make sure that even though we rely on these things, they power so much productivity, so much improvements in our gross domestic product globally, that things can still happen, things can still go wrong. And because we rely on them more than we ever have before, when things go wrong, they can go really, really wrong and create supply disruptions. They can create quality issues, not just the quality of the barcode and label itself, but quality of the finished product. It could be the wrong configuration. It could have um, the wrong parts there. And still to this day, no matter how much technology we have, I have colleagues that do a lot with RFID. Even so, the barcode is still the most widely used and cost-effective way to track and identify components. The amount of data you can put on these things, especially with 2D type barcodes, it's cheaper than even solid-state hard drives on a per bit scale. I can print a label for a fraction of a penny, and I can in a single data matrix code can hold up to 4 kilobytes of data. So I just cannot beat that on a data density scale. And so we're going to explore some of the issues when these things fail as we go on this talk and see if there's ways we can maybe mitigate those. But first, another polling question. I'm going to launch this. I want to understand the biggest failure impacts you've seen from poor label quality. I heard, and Travis heard a lot about these at the AIAG Summit. People that have stopped by our booth to talk about this. But I'm curious to hear from the attendees here, what are some of the things, the biggest impacts? If you think about an FMEA, even though I haven't introduced that concept yet, this would be the severity dimension of the RPN score. What are things that are really, when things do go wrong with barcode quality, with label quality, what are some of the things that you're seeing in your operations from your standpoint? I'll do this for just 10 more seconds. I've got about a third of the people putting in their answers so far. Really curious to see what are some of the impacts associated with poor label quality. All right, last second, last chance to vote. All right, let's share the results. Okay, let's see, sharing results. So it looks like customer chargebacks is the biggest thing. We do hear that a lot. It's not just limited to automotive, but certainly an automotive supply chain where you rely on just-in-time manufacturing and reliance of barcodes when they're not working. That can be extremely disruptive, and a lot of tier ones and assemblers have put in chargebacks into their contract language. Um, Sometimes yeah, process downtime I think is a good one. Um, if they don't want to deal with it, they'll send it back to you for rework. It could be a big rework or potentially just rework in the nature of the um, packaging piece. Okay. And again, I'll share these back um, at the close. All right. So how is FMEA or process failure modes effects analysis as well, PFMEA? How are these really going to be helpful? Well, think about it from a historical perspective. These were things that were first used by the U.S. military. They came up with this system of ranking risk and giving it a priority number in order to improve quality issues for munition manufacturing during the 40s. You don't have to be a historian to know how impactful this can be. There's lots of books out there around victory and loss in terms of war, and so much of it comes down to the logistics piece and being able to get weapons to the right place, supply lines, etc. And if your supply of munitions is short because you're experiencing quality issues in the manufacturing side, you're not going to win that war. Um, but famously, the U.S. military did adopt FMEAs, improved quality dramatically, and was able to win that important World War II. Additionally, was improved. These types of tools were so incredible that they were adapted for increasing other project or decreasing risks in other projects. It was vital to success of the Apollo missions in the 60s. In the 70s, Ford adopted it in response to safety and quality issues that they were experiencing. And I think we really have never turned back since. It's still that MIL standard that was adopted by the US military in the 40s is still the citation used when adopting FMEA type process quality system. And you can learn more about that in the history of FMEAs here. Effectively, we're going to focus on three dimensions of a process. One is the severity. How severe is a failure? The second is occurrence. How often is this failure seen? And then detectability. Can I catch this before it becomes a bigger issue? Or can I prevent it? So that's the detectability score. For your RPN, this is a product. It's a product of severity, occurrence, and detectability. And like golf scores, minimum is the best. Low scores are great. The lowest score you can get is a 1, 1 times 1 times 1. The highest score you can get is 1,000, 10 times 10 times 10. And generally speaking, your scoring methodology is relative, and you decide that internally. Because what this is going to give you is a priority number. It's going to show you which are the biggest risk factors to address first. So similar to a Pareto, it's sort of a preventative measure. Pareto will tell you what is the most impactful thing to do in response to what you're seeing from failures. FMEA might prevent those from happening in the first place because you're giving it a value to what you think is the risk factor based on your current controls. And I have to mention that there are, even though this is the same MIL standard from the 40s, there have been some advances in FMEA. AIAG and FDA and the VDA from Germany worked together on improvements to the FMEA. Some of the critiques of the FMEA is it is a bit static and focused more narrowly. And so some of the improvements, as opposed to using RPN numbers, you can use a stepwise approach to grade. It standardizes definitions for severity, occurrence, and detection that are specific to the automotive industry, which can be good, especially if you're looking at the importance of a nut and a bolt versus a internal combustion engine. can help weigh the importance of those things. And it does replace the RPN with action priority tables, which is a different way to do a force ranking of where we should get going. For today, we're going to stick with the classic FMEA because even though this is part of the automotive ecosystem, you can treat labeling pretty narrowly because you get media and then you print media and it goes on a item package, it goes on a part or kit, and so I can treat that pretty narrowly. Um, Although the disruptions and some of the things we talked about earlier will still cascade down. For improving this process, I can just look at those few steps related to label processing. So in occurrence, if something is extremely unlikely to occur, so think about one defective part per million, I would rank that a 1. That's not gonna, you're not gonna see that very often. Especially if you're printing 1,000 labels a day, you might go 3 years before seeing a defect. An occurrence of 5 is typically going to be something like a percent. This is going to happen maybe 10 times a day if you're printing 1,000 labels per day, 10,000 dBPM. 9, you're just going to, it's a systematic issue. You're going to see this a lot. And then, you can kind of filter the numbers in between because it's a continuous scale. In terms of severity, 1 would be little impact to your operations metrics, safety, quality, delivery, cost. You would be very low impact. So even if you did have a failure, you wouldn't see this in your operations metrics. 5 would be a moderate impact. This could be a chargeback. This could be longer lead times. It could be more labor costs. Severity of 9 is really saved for very risky endeavors, health and human impacts, things that could cause injury, severe injury, or they could be just massive financial costs to your operations. But you typically save some of the highest severity scores for customer impacts that are health and injury. In terms of detectability, a 1 would be basically there is no chance for this leaving my facility. I will catch this mistake 100% of the time. 5 might indicate a detectability that you're doing a spot check and using statistical process control. Maybe you have a destructive test, and so you can't physically inspect 100% of everything you make. And so you're applying statistics to a sampling process. So if there are, instances of nonconformance, they may escape because you're only doing spot check, but in general, you're going to detect a bad lot. Something went wrong, and I'm going to find that. So that might be a 5. And then 9 is I have no visibility. I would not be able to detect this problem whatsoever. So that's our grading system. As far as an FMEA table, you typically format it this way. And I'm going to give this spreadsheet out to all the attendees. Thanks for coming. You can organize your spreadsheet typically by the process step. And so if you have lots of different process steps, each one would get their own FMEA type document. I have this one rev controlled with my project ID, revision history. This is my potential failure mode, thing that I'm worried about. What effect or impact would come from that? And so, like a fishbone diagram, a field failure might be due to multiple different things. And then that would give me my severity score. In order to understand occurrence and controls, I would want to know what my causes were. And so that's here in this column. What are the causes of these failure effects? And then what am I doing to control currently for that failure mode, for that cause? And we'll kind of go into this. We'll open this up and look at it in a minute. But effectively, to do this, you got to build a team of subject matter experts, people that own the process. And what I found is, people that they worry about this stuff. It keeps them up at night. People that are going to have the experience to know what can go wrong, that have seen it before. Those are great people to build a team around to help do the FMEA. So you start with the process step, you brainstorm the different failure modes, you kind of branch out, and then you go through line by line and rank things. And doing this all at once is very helpful because it'll improve the relative score of the RPN. And this is kind of This color-coded graph here is the product of severity, occurrence, and detectability. And it tells you where to put some of your effort to drive the biggest quality improvements over time. In terms of categorizing the failure modes, if I start here with process label printing, this is what I'm talking about in terms of branching out. The failure modes, I'll kind of zoom in here on field failures. So this would basically be something that that happened to the label after it left your facility. The failure effect could be that the ribbon, the printed information, the indicia is rubbing off. You could have a label issue where it's fading, potentially. There could be label coding issues where it's flaking off, again, after it's been printed, after it's left your facility. It could fall off the substrate, so you could have an adhesive failure, or the print could degrade. So these are basically be the 5 most common effects that you would see in a label after it left. And you can generally state the cause of this is media design. You're using the label probably in a harsher environment than what it's intended to go into, or maybe it's the wrong ribbon, it's incompatible with that particular substrate. It could be the wrong adhesive type. It's not meant for cold or shipping or different surfaces, and so that would be the cause that you would go and then address. So if I think about these failure modes at the highest level, things happening after it leaves your facility, having the wrong data in the barcode, having the label be of the wrong format or have maybe missing fields, not being scannable, or creating process downtime. The effects that can cause these are really vast. We talked a little bit about media issues. But there's also things that are caused by the printer itself. You guys use printers every day. The printers jam, leads to downtime. The ribbons wrinkle inside the printers. They may not be able to keep out debris. You could have print head failure, pixel. This is just a partial list. If I add in the other things, unscannable codes from the printer, poor print quality, a partial print, you can have uneven print head pressure, and basically collecting all of these from our tech support team and from the field where we're helping our customers. There's a lot of things that could go wrong in this. So, that, and then the root cause, this is something that we've gotten a lot of experience. We have a very large field application engineering team that are working on these types of issues. But you can do a root cause analysis to get to the most common causes that you see. And I won't go over them here in detail because I do want to go walk through a few examples. So let's share the spreadsheet. Okay. So I have here a couple examples of label printing process in my scan sheet where I know the severity of these things. You guys pointed out some potential, all of these would most likely lead to a chargeback, for instance, which would cause me rework, cost me financially, and cost me reputationally with that supplier. And right now, I'm going to assume that this isn't the most common thing that you see, but it's maybe like 1 out of 100 labels. You get a little ribbon wrinkle, and so that would be your occurrence. Kind of at that 1% mark. Low contrast or bar shrinkage. This can happen if I change print settings or the media changes, but it's probably not too common. I actually see print density being too high as more common because what happens is if you've ever seen a little bit of fading, the first thing you do on the printer is you crank up your burn setting, how hot the print head gets, and most people will just leave it there. And over time, that can cause ghosting, double prints, because you're just putting too much energy into the ribbon. It has to release somewhere, and that resin gets transferred in places that you don't intend it to transfer. For the most part, I'm catching these by an exit scan. An exit scan is a pretty good detection method because I'm showing I can read that barcode when it left. And if I can't read the barcode, I'm going to detect it and I'm going to have to do rework right there. So detectability is typically good because you're almost always doing an exit scan. Um, the problem is that scanner technology is really good. And so if you have a supplier that's doing a verification step, they may grade your barcode a D, even though it was scanned by you. Um, Additionally, if you have a 1D code and it has a wrinkle through it, if you move the scanner around enough, you're likely to find a region where you can get a 1D read off of it. So I think in these cases, detectability doing this is typically a 5, because if especially if they're doing a verification or holding you to an ANSI grade, if you're just doing an exit scan, most of these things you won't catch because I'll still be able to get a barcode scan, even though you're going to get a chargeback from that. And so you could see the RPNs associated with that here. All right, let's bounce back over to the talk. All right. So again, a snapshot here, you can see some of the RPN scores. Sometimes I don't do stuff, and other times, okay, I really need to implement a change. And your change, how you're going to implement this is going to be determined by the different types of failure modes. Sometimes like a ribbon wrinkle or debris, it's kind of random. You'll see it once or twice. But you know, it's harder, random errors are harder to track down. Things that are systematic are typically easier to find. A systematic error might be like a pixel is burned out. And so that happens for every single label. So if you need to clean your print head, your platen roller has debris on it, those are systematic. They repeat over and over again. Those are typically easier to detect for, because sampling, a low cost sampling method is going to work. For random, these are really hard to detect. And if your AQL level for detection, if it's pretty strict, you may need to do 100% inspection to catch all the random issues. Um, and know that the failure can happen during the process. We talked about printing issues, label issues, or it could happen after it's left you. So field failures happening in the field are really hard to detect because they've already escaped you. So we'll talk about some solutions to those as well. But first, a little bit on barcode grading, the difference between validation and verification. I mentioned briefly that there are these ANSI grades where um, you might be printing a D barcode, and so your scanners work, but some scanners are going to fail to read this. And the D score is based on, in verification standards, there's ISO standards that measure 8 different dimensions for both 1D and 2D codes. It's specific to each symbology, and it's looking for contrast. It's looking for line edge roughness. It's looking for different defects. It's looking for skew in the case of 2D barcodes. Is it stretched? And it also validates that the data you meant to print is the correct data that I'm scanning. Uh, when you just do an exit scan, you're basically validating. You're validating that I can read it, read the data, and then it passes. And so that's really a pass fail. So, you know, an F is a fail, and you're doing an exit scan, you're only detecting a pass fail on that type of control. Whereas verification allows you to make an informed decision on what is really going on, and is this going to be permissible at my supplier? An example of verification of 1D barcodes would be something like a code 129 like this. This would be a pristine barcode. And then, you know, this would be a faded barcode. So in this case, my bar contrast is going to be too low to potentially even read, because I need a high black and a low white in order to read on the scanner. Additionally, when you have bar contrast issues, sometimes the bars will shrink, and so the thickness of these won't be thick enough to register as the appropriate encoded bit. And now I'm going to get data issues along with scanning issues. Um, This would, be an example of a dirty or debris background. Again, reduces contrast. Lots of line edge roughness here. These are going to be failed barcodes. An example of 2D barcodes, again, the pristine barcodes, we have a QR code, a data matrix code. This is what fading would look like. Some of the dimensions that you grade 1D and 2D on are similar, like symbol contrast, decodability, and others are unique. With 2D codes, because they don't really have the same quiet zones that exist in 1D codes, they use fixed patterns to indicate to an optical reader, a 2D reader, where the pattern starts and stops. And so if you have damage to some of these indicators here, you're going to have an impossible time reading this. And so the ISO standards will look for the presence of these fixed patterns and look and see if they're damaged or not. You can also have things like axial non-uniformities, stretching. This is pretty common when label templates have been messed with. Someone needs to shrink or try to fit it into a specific spot. And now what the imager is looking for is not what it's getting because I have skewed it. And you can get that in an axial way and in a non-axial way where you're stretching and distorting in different ways. This could also happen if the media is stretched as well. So it's not just about what the print head is doing, but if the media stretches, especially with vinyl type materials, you can get this type of skew and bad grades as well. Okay, so we're going to go to poll question number 3. And it goes back to those 5 failure modes. And I want to know which of these failure modes are you seeing most often in your operation. So when you do get label quality issues, label printing issues in that process, are you seeing more downtime issues, barcodes that can't be read? Maybe they can be read, but I'm having incorrect data, or I can't trace the data back to the system itself. Label issues in the field where you're getting complaints, hey, this is faded. What I shipped was perfect, but now it's not working. Or maybe template challenges, template issues, formatting issues, customer specific standards that you're trying to meet be relevant as well. All right, 10 more seconds to vote. Get your votes in. I do appreciate the votes. It kind of helps us as we iterate on this, make sure that we're talking about the right impacts to your business. All right, I'm going to wrap it up. Last second to vote. All right, let's check the results. So maybe not surprising, unscannable barcodes was the number 1. We are getting some reports of label field failures, downtime in templates, but just a small sampling there. Kind of interesting that the barcode itself is still number 1 in terms of the mode that we see failing. All right, back to the talk. So what can you do now that I know I want to prevent this from happening? There's lots of different control plans that you can put into place. And we'll talk about preventative measures as well. But for controls, QA testing has always been a really powerful way. Put in a control plan, measure it. Typically in QA testing, I'm going to do a sampling based on AQL. I've provided an AQL calculator here if you're not aware. It helps you figure out how much sampling you have to do for a given lot size based on different types of errors, defects, critical defects versus major versus minor, and it will give you a threshold. But again, a lot of times that's just pass-fail. These are in conformance on this rate, and so if I sample, statistically speaking, I should have this level of quality. There's different ways you can do inspection. If you want to be certain, it would be 100% is the best you could do. We talked about you can't do this with destructive testing. And then, the labor cost associated with doing a manual inspection is very high. And so are there ways you could do this in an automatic way to reduce your cost as well? I guess in the best classical sense, if you can design for this, basically prevent it from happening in the first place, pokey yoke, or what you see is what you get, a WYSIWYG design, you could prevent the occurrence in the beginning. And so maybe part of your RPN action is to just do a redesign, and or change your system. But we will also want to introduce some simple cost-effective ways that don't force you to change what you're doing today dramatically or add a lot of cost, to help reduce some of these RPNs. So 4 simple things you can do today, if you're not already doing these, are some kind of a rub test. If you do a label rub test, you're basically making sure that that ribbon is designed to be printed on that label. And it's a really good, cheap way. You can do it with sampling. It's a really good, cheap way to check to make sure that that match is correct. Probably the most common mistake is wrong ribbon, and a quick rub test can save you a lot of hassle later on. You can implement supplier quality scorecards. This is in terms of making sure that your suppliers are informing you of any potential change so you can requalify it. A lot of times labels are considered an office supply, and so change management announcements to people that are using the labels isn't well done. It's not well documented. Even something as simple as a liner change could jam up your printer if it's done poorly, or could cause other issues as well. So implementing a supplier quality scorecard, setting those expectations is pretty good. We'll talk a little bit about automated barcode verification. It's one of those ways you can do 100% automated inspection to make sure you're not getting any failed barcodes. We'll also talk about a label management solution as a simple way. In terms of QA rub test, the gold standard is ASTM D5264. I've used these Sutherland rub testers in every business I've been in. They work. You can set up your own spec. You can, typically use a Q-tip, and set a number of rubs that you want to do. It can be very, very fast test to make sure that you have the abrasion resistance to go through your environment, whether that's a shipping and logistic type application where normal kind of wear and tear during the carrier process from point A to point B via ground transportation, or if it's a traceability label that you need it to last for 15, 20 years under hood. That I would use a higher rub, probably some chemical exposure as well to make sure that I printed it effectively. And so this has always been a really good tool. Another one is supplier quality scorecards. I put a link in here for those that want to learn more. I think this is fairly standard at this point. I just pointed out because a lot of people neglect the label and the ribbon from their supplier quality scorecard process because we don't see it as a critical component, even though it carries data and information that is really critical to my operation. And so I think that you should hold your suppliers that are providing you with labels and ribbons at the highest standard as well, because those issues can cause a lot of pain. Quality scorecards are going to improve the collaboration that you have with those vendors. It's going to help you improve them and their abilities over time, and also allow you to benchmark to make sure that you're working with customers that are impacting your operations positively. In terms of the unscannable barcodes, this was indicated in the poll as a very high priority failure mode. There is something that you can do that's effectively a bolt-on to your printer. We've designed this system, online data verification. It's going to verify every single barcode and label that's printed out of the printer in real time. So you're getting 100% inspection, no additional labor costs, and I can scan up to 50 barcodes per label at speed and do the dimensional analysis against those symbologies, all 8 to 10 dimensions, depending if it's a 1D or 2D barcode, and then record that data. If there are any issues in those verification reports, and again, you can set the threshold that you want. If you want only B and above, you can set that threshold. So where if we verify against that standard and it's a C, the label will get sucked back into the printer and overstruck so that you can't use it. And we'll print a replacement label for you automatically. So it's a really powerful tool to make those detectability scores go to a 1 because I am preventing any possible way of a bad unscannable barcode from leaving your facility. And it's just an additional accessory for some of our enterprise printers. It's available on the T6000 and the T8000. We have it up to 6 inches, and it is compatible with RFID as well. So this is an option. I included a link to a video so you can see how it works. This is a CMOS camera using IR, just like a barcode scanner, to take the image in real time and process it. And it integrates with a bunch of different software providers to provide you with an archive or record of everything that you printed. And then on the last bit of recommendations, you can implement a label management solution. Travis is going to tell you a little bit about that.
Yeah, sure. Thank you, Andy. That's a lot of information, and there's a lot of potential failure points along the way for a label. And really, a label is a supplier's, it's their face, it's their name tag, it's how they communicate to their customers. So it's essential that they have really good software that enables them to basically build a label in a fashion that it is what you see is what you get, and that's where CodeSoft comes into place. It allows you to build that label to the standard that is required for the product that you're delivering. So you don't have to worry about your label design and how do I make this all come together. We have software that enables that to occur. So you can focus on the things that are important to you and creating the actual products for your customers. With that, the CodeSoft Enterprise solution, you can then leverage label archive, so right in the middle, and that ties in with that ODV 2D solution that Andy just mentioned. What it allows you to do is to be able to design a label, have that label go through a quality assurance process, your internal one, to make sure it's meeting all of the requirements, and then you can publish that label to production. So only those labels that have went through that approval process are available for use in production. And then it will also track what was printed, when it was printed, where it was printed, how many were printed, and records that all inside Label Archive. And then for those suppliers that or they have customers that need to be able to control their labeling outside of their environment. So let's think third-party suppliers to you. You can then expose through the TechLink Central solution a label into their environment. So they'd be able to log in through a web browser and they would be able to access that label that you have as a standard and then print that in their environment. So when they deliver it to you, you're getting what you asked for. And that really takes the confusion around how is one supplier going to handle their labeling. You can kind of help that process to ensure that you're getting what you need. So that's kind of, we have more tools, of course, but in respect for your time and for the subject, that's what we wanted to talk about.
Yeah, thanks, Travis. Okay, so these are the recommendations that we kind of went through. So assuming you have current controls in place that look like something like this, exit scans, I'm using work instructions to make sure I pick the right thing. I have some supplier quality already, so I'm assuming you already have that. These recommendations would, because they go after detectability, could dramatically reduce your RPNs. You can see what those look like here. And so this is like four very simple things you can do to improve your label quality and improve this FMEA. But again, what's specific to you is going to depend on your current controls, how you assess the severity of your process, and the occurrence, how often you're seeing these types of failures in your operation. And so what we're going to do is give you this FMEA document so you can go with your team, sit down. We've brainstormed a lot of the root causes, the potential failure effects, and you can do your own scoring, enter your own controls, and see if some of these recommendations might help or benefit you. And so that's really what we wanted to cover today. So in review, we highly recommend using FMEA to improve your label quality. 4 easy things: rub testing, supplier quality scorecards, doing 100% barcode verification as part of your label printing, and then installing a robust label management solution. These are the things that we recommend you do to improve those scores. And then, we have some things that we can do as a follow-up. And these slides will be shared as well for your convenience. You can look this up and scan the QR code to request a labeling assessment from TechLinks, or to download more of our automotive solutions. ODV is one of our automotive solutions. We have a lot of others that can help improve your label quality. And here's some contact information. I'm going to stop the webinar at this point and stay on the line. Travis and I are going to stay on the line and answer any questions that you have. But I really thank you for your attention and your interest in this topic. And so we will go and move to the Q&A portion.